All right, we are live again this week. Happy to have with us Michael Newton. Michael is going to be sharing and actually building a type provider from scratch. So for all of you who have so far put off building a type provider, today is your lucky day. Michael is a developer, architect, trainer, and consultant. He runs Maven Limited along with his wife, providing training and consultancy. If it relates to learning about or using anything that relates to .NET, functional programming, or build infrastructure tooling, he and they can probably help you. You can read a lot of their material up on Michael's blog at http://blog.maven.co.uk. Michael, thank you for joining us today, and we look forward to hearing what you have to show us.
Thank you. Let's hope it all works. So thanks, Ron. And I was going to do a quick intro, but Ryan's done that for me, so we'll get rid of that. But I thought I'd run through kind of the basics of building a type provider. There is some fairly good documentation up on the MSDN website, but it kind of leaves, in my mind, a fair number of questions hanging, and it took me a while to kind of get the first type provider I tried to build up and going. So I'm actually going to work through the whole process. I've got, hopefully you can see a screen here with directory listing of what I'm going to start with. So this is just a simple single project Xamarin Studio solution. I haven't done anything yet. You can see kind of the standard, this is a class here and all that kind of stuff. And the only other thing I've added is I'm going to be working with Packet. So I've put Packet Bootstrapper and Packet in this directory so we can get going. So I don't know if any of you are going to try and follow along. That would be quite brave on your parts, but we can give it a go. And if you're listening to the recording, you can pause and unpause as you're going along. But I'll try and explain everything kind of step by step. And the plan is that we're going to start by getting the dependencies you need to build a type provider. We're going to then build the simplest possible thing that the F# compiler will recognize as a type provider, even though it doesn't actually provide any types. And then we're just going to gradually iterate from there, creating a static type with no configuration, adding some configuration, moving along through that path till hopefully by the end of the session, we should have something that may not be useful in itself, but will have shown you enough different things that you could build something useful using those same techniques. So let's give this a go. So one of the things you need to know about type providers is that there can be issues with including binary dependencies in your type provider, especially if they're strongly named, because the way that type providers work is they are kind of run both by the compiler at compile time to create types. So the compiler will go off and run the code in your type provider. But they'll also, then of course, you might want to, you'll have a reference to your type provider assembly at runtime as well, unless you play some very funky tricks to get rid of it. So what you need to do at that point is you want to rely as much as possible on having source dependencies rather than binary dependencies. So that's the reason why I would I would recommend this anyway, because I've had issues with NuGet in the past, but especially if you're building type providers, I would strongly recommend you go with Packet, because you will end up using a lot more source dependencies than you would normally. And in fact, even the official type provider API is actually supplied as a set of source files that you can include in your package. So let's get going and actually get those referenced. So for those of you who haven't used Packet before, what you do is dependencies. That lists all of the dependencies for a solution. So you want this at the solution level. And let's have a quick look. So we're going to drop a couple of things in there. I'm probably just going to cut and paste these because it gets boring watching me type some of these things. So these are going to be GitHub references. Packet will actually go off and it will get these files from GitHub direct. So here I've got a GitHub reference to FS Projects F# type provider starter pack, and we want the provided types FSI file and the provided types FS file. If you've not seen an FSI file before, it's effectively just a way of specifying the external signature of your module that's in the accompanying FS file. So you can go and look that up if you're interested. So we've got that. That's at the solution level. We've said these dependencies are available. Now at the project level, I've got them both in the same directory just to make life easier. But this would go with your project. You have a packet references file, and this is the things from your solution dependencies that this particular project wants to reference. In this case, we're going to grab a couple of file references. Let's make sure we're in insert mode before we try and paste. Otherwise, Vim can do interesting things. So there you go. We've added a reference. We've said that we want a reference to these two files, and this bit at the end here says that we're going to set. We're going to put the file in a subdirectory in our solution called provided types. Sorry, a solution folder called provided types. Having set those two up, if I just show you in Xamarin at the moment, you'll see that at the moment we only have the assembly info that was generated for us when we created the project, and we've got our component page, our component FS file, but that's it. If we run this will go off and it will grab some stuff from GitHub, and that's lovely because about 20 minutes ago my internet was playing up something chronic. So I'm glad that that kind of worked fairly swiftly. So if we now have a look at our Xamarin project, it will disappear for a moment because Xamarin's realized it's changed and it will want to reload it. And we see we've now got this solution folder, this project folder, even provided types, and we've got these two files in here, provided types FS, and which you can see all the Microsoft stuff on, and there is a lot of code in there. Yeah, about 3,000 lines of code. I would generally avoid reading that if you can possibly avoid it. And the FSI file, as I said, that's just the public interface that you want to expose. And in this case, it just hides a bunch of kind of internal bits that you don't really want to look at too closely. Right, so we've got our references now. We can actually build a type provider. We can create something that that the F# compiler will recognize as a type provider. By the way, the Q&A session is open, so if you have questions as you go along, then do feel free to ask them. One thing to note is that particularly if you don't really know what type providers are, it would be good to ask, because I'm not really going to talk about that. I'm only going to talk about kind of how they work. So if you haven't seen a type provider in action before or played with one, if you just post a quick question up, and I'll break off at some point and talk about that slightly.
By the way, Michael, the Toronto or Functional Toronto group has several people joining, and they said hello. Hello.
I will say hello back to Toronto. It must be a sort of lunchtime session for you guys. So enjoy your lunch as I carry on. So what do we need to build a type provider? I prefer working in modules to namespaces, so I'm just going to drop a module in there instead of a namespace. We'll take that out for a moment. So the first thing is that type provider assemblies, as we were saying, what happens is basically the F# compiler gets halfway through the compile process, and then it stops and it runs the arbitrary code in your type provider assembly to generate a bunch of types. It will only look for type provider classes, things which implement the type provider interface, in assemblies that have a type provider assembly marker attribute. And I think that's purely just kind of a performance optimization thing. The other side of it is that if you've ever tried to load a type provider in Visual Studio, you will have seen a kind of security pop-up saying, you're loading a type provider. So I think it's also partly how it keeps track of which ones you've said before that you are. So I need a namespace there as well. So let's get a couple of namespaces open. So there's the.
Michael, it sounds like your audio is cutting out a bit.
Yep, Hello?
Yes, I think it is coming and going a little bit.
Am I back now, though?
Yes, you're back.
Yes, good. Sorry, it suddenly poked up something saying I've muted myself, but I don't actually know how. Must be some shortcut or something. Yeah, so F# core compiler services, that's built into the core libraries. And we also have this provider implementation, what you've actually included by referencing this provided types file here. So now we have our type provider assembly in our namespace. So we've now flagged this assembly as containing a type provider. And the only other thing at this point we need to do is we need to create a class that implements the Am I muted?
Seems like it's coming on and off again as well.
Yeah, I think it might think I'm typing too loudly. Not quite sure. I'll have that in focus for the moment. Okay, so we just need a type here. Consistent on my capitalization. Class equals that. And we're just going to inherit a class that's in that. At this point, that is a complete and working type provider, or at least it should be. Let's actually build it and find out. Yep, so we've got a successful build there. And we could go and reference this in our script file. We'll do that in a moment, but I won't bother just yet because, as I said, this won't actually provide any types at the moment. But it's just nice to sort of start getting the hang of how the compiler hooks into the type provider process. You know, this is kind of the incantation you have to jump through to make the compiler recognize that your DLL is a type provider. Let's actually get it to try and provide a type then. Let's see what we can do. So at this point, we need to start doing a few funky things. So a reference to inject stuff into as we run our arbitrary type creating code. So we'll open up system reflection. We'll want to use some of the methods from the base class that we're inheriting from. So we'll put a self reference in there. We'll just call it this. That's my kind of personal preference. We'll also need to choose a namespace to inject our types into. So we'll have a hangout live dot provided namespace. I'll change this one to something different actually, so that we can tell which bits are in the DLL and which bits we're generating. So that's our namespace. We'll compiler sets the executing assembly to be the assembly that you're injecting stuff into, which is quite nice. So you can just call assembly.getExecutingAssembly, and you kind of get that. And looks like I'm getting a question, why is it called type provider for namespaces? I think the answer there is that there are actually a couple of others, but to be honest, I've only ever played with this one. Basically, the type provider for namespaces, we'll get there in a moment, but it allows you to inject a namespace with types in it into the assembly that's being built by the compiler.
Do you happen to know the other options?
I don't offhand, I'm afraid. I would need to go and have a look. I've never seen anyone use any others. I think there are others, but I couldn't tell you what they were offhand. So let's have a look. So we know the namespace we're gonna sort of inject stuff into, and which assembly it's going to be in. And then what I'm going to do is I'm going to create a property, which will obviously type in a moment. Keeps on muting me. We'll have a provided property. We need to give this a bunch of stuff. We'll call it static property because writing name, I know. We need to give it a type. So this property will be a string type. We'll use a constructor setter to set the isStatic of the property to true. And then we have some what it calls getter code. And that's just a function that will then return a value, and that property will then have that value. So we're always going to return hello world. This is going to be one of the longest hello world examples you've ever seen, but it gets us going. Am I on the right? Yeah. So let's my type. So this is the type we're actually going to provide that will have this property. We're going to have a provided type, and you can kind of have a hierarchy of types, but the top of your hierarchy has to be injected into the assembly, and all of the others need to be injected into kind of the next thing up in the hierarchy. So this is the top of our hierarchy. So this one, we actually need to tell it which assembly and namespace we want it to exist in. We need to give it a name. And also the underlying type that are. Now this gets slightly interesting because there are actually two types of type provider. I'm only going to talk about something called a generative, not a generative, an erased type provider. The other type is the generative types. Can I implement a static provided property with getter and setter? Maybe in a moment. Sorry, Sergey's asking. So I'm only going to talk about erased type providers. Generating type providers are a bit different. I'm not going to talk about them here, but feel free to sort of email or Twitter me questions later. Sorry, Ryan, is there any way of putting that question back up? Because otherwise I'm going to forget about it, but I would like to answer it at some point for Sergey. If not, don't worry.
Yes, if you go to, there should be a little drop down on the questions, and you could select answered questions.
Ah, thank you. Great. So this is a erasing type provider. So what happens is that this will kind of inject metadata the F# compiler knows how to read, and it will treat it as the type you've provided. This underlying type here, this some type of object, that's actually the underlying kind of CLR runtime type that this thing will actually be. So if you go off and you try and reference something that uses this type provider from another .NET language, so you're two references away now because only the F# compiler knows about type providers. So if you try and reference your type provider assembly from a C# program, nothing will happen. If you create an F# library which references your type provider, it will get the provided types. But if you expose them publicly and you try and reference them from C# or VB.NET or whatever, this type here is the one you'll get, not the type that you've actually created with the type provider. So that's just something to be aware of. Generating type providers get around that issue, but they get a whole host of new issues instead. So kind of a separate topic, even if they do share some of the same API. So we've got a type. So we've got a couple of private bindings within our type. We've got this property, we've got this type, and now we just need a. So anytime that this is created, we'll go off and run this code. So what we do is we add property to, and then we'll call a method on the base class called add namespace, hence the type provider for namespaces naming, and we're adding a namespace called namespace, and we're injecting a list of types into it. And at the moment, we only have the one type. So we should be good to go, I hope. So we've added our self modifier, so we can call that add to namespaces. We've got our namespace in the assembly we're injecting into. We've got a property.
Michael, we've got another question from Christopher Atkins. Would you ever use anything besides obj or an object? Maybe a dynamic object from the DLR?
I hadn't really thought about the idea of using dynamic object, I must admit. I can't quite think of the implications of that offhand.
I know that the F# data SQL client uses a dynamic object as a base for easier serialization into things like JSON and things like that.
Yeah, yeah. So one thing you can do quite often is, say, for example, if you want to be able to do reflection or other similar things on your objects, you might say create an object that's that kind of contains your core logic, but in a non-type provided way. I'm trying to think of a good example offhand and blanking horribly. The other one which you see quite a lot is quite often you'll kind of have the underlying object being a dictionary or a map, but then you can, if someone was referencing it from C#, they'd get a dictionary, but if they reference it from F#, then they get a nice sort of object with fields representing each of the things in the dictionary and that kind of stuff. So there are a few tips, a few tricks you can play using things other than obj. The other thing is that you can actually, you'll see when we run stuff in the in F# interactive in a moment, you can actually see the underlying arrays type in F#, and you can cast back to it if you really want to. And so again, there might be places where you want that to happen. Right, let's build this. See what happens. So that built successfully, which is good. I don't want to load the file here at the moment. What I need to do, because you can't unfortunately sort of have interactive type providers, you need to actually reference a compiled DLL. So we should be able to do that, whatever we called it. Actually going to work. Cool. So we should have our provider namespace. We should also have our provided. Is that wrong? No, or it could just be not working. This is not unusual with type providers. Yeah, let's rebuild that. It's now claiming there's no public type provider classes, which is interesting because there most definitely is. One thing you'll notice with building type providers is that often if you're actually building them in the same process that your IntelliSense is trying to reference them from, you often get the IntelliSense ending up out of sync with what you've actually built. So I'm just going to quickly restart Xamarin in the hope that that's what's happened here.
I've also found in the past when I've tried doing some simple things that it seemed like if you reuse parts or the same namespace, that could cause problems. Like if we try to generate into an existing namespace, that sometimes seemed to fail to work correctly. I'm not sure if that's a valid finding, but that's what it seemed like.
I've often had all kinds of weird things happen with type providers, it has to be said. So, oh, there we go. See, yes, I haven't actually changed any of the code or recompiled, but suddenly I have IntelliSense. Yeah, injecting into kind of existing namespaces can sometimes have weird effects. It's also very easy to generate things that kind of shadow themselves, which is also can have interesting side effects. So let's not open that namespace. Let's just go provided dot static type dot static property. So there you go. We have a type provider. It's given us a static property. Select all of that. You can even see, hopefully the font is big enough, that the value of our static property is hello world. We're getting there. Let's close those. So this is all fine and dandy, but obviously you could have written that much more concisely, just creating an F# type with a static property. So let's have a quick look at what we're actually doing under the hood here and see if we can take things a little bit further. But first, I'm going to have a quick look at this line of code here, because obviously whatever this thing here is actually not just a string. The sort of weird angle bracket double @ sign thing is actually a set of operators in F#. And these represent something called a quotation. And I'm just going to briefly diverge, because unless you know what quotations are, and most people haven't had any reason to use them, going any further with the type providers is just going to cause a sort of massive confusion. So I've got some examples that we can have a quick look at. Let's get that in a moment. And let me grab my examples from over here. Bam. That's also scrolled my thing, so obviously they're too long. So F# quotations, they exist in the F# core library. They're not type provider specific. And they're a kind of slightly weird construct, because what you do with a quotation is you kind of wrap a piece of code in a quotation. And when the compiler gets to compiling that piece of your code, it starts compiling it and it kind of creates an abstract syntax tree. And then it stops. And rather than actually compiling the code down to sort of IL to run on the runtime, it actually gives you back the abstract syntax tree, and then you can do whatever you like with it. So several of the libraries which are doing things like compiling to JavaScript or compiling to sort of run on GPU and that kind of stuff, they're actually, several of them are using this kind of quotation technology under the hood to kind of create an AST from the F# code, and then rather than continuing that process to create a .NET DLL, they kind of grab that and instead they feed it into a JavaScript generator or a GPU instruction generator or whatever. So let's have a look at what that looks like. So let's open our F# quotations namespace. And so we'll start off with a simple function. So we've got our add function. It takes two parameters and it adds them together. Okay, strictly it's curried, so you know what I mean. And we could wrap an expression that uses this function in quotations and see what happens. So let's do that. And we get a bunch of stuff down here. So hopefully you can all see this down here if I highlight it for a moment. So what we're saying is that we've got an expression. So the quotations return an expression. And the expression consists of a call expression. It's calling a static method. So if it was an instance method, this would be the class that the method was on, but there isn't. It's called add. This is the string representation in FSI, but that is actually kind of the method info for the add method that's being represented there. And it's being fed two values, just static values, the number 1 and the number 2. But it hasn't actually evaluated that. It hasn't actually added those two numbers together. It's just handing us back that representation of the tree. Where life starts becoming slightly stranger is that then you can actually inject expressions into other expressions as long as the types match. Load up. So here we actually have a function of expression to expression. So it takes an expression X and it injects it into being the first parameter to the add argument. So if we now say give it an expression of 10. We can't just feed it the actual literal 10. We have to feed it an expression. It's added some debug information down here, which we can ignore. That's just there for sort of FSI to keep track of what's happening. But we've got a let binding here saying we're let binding something with a name of x. So that's our x here. And we're binding the value of it to 10. And we are then returning this lambda, which, because add takes 2 parameters, so when we partially apply it by applying the first one, we get back another function that takes a single parameter called, it's decided to call y, and then we'll call add with x and y. So we're kind of building up these trees, and I think it refers to it as splicing them together in the documentation, if I remember correctly. And we can get arbitrarily complicated with these things. We can so we can have a sort of cos of 5 times x quotation, and we can also, this gets important with type providers, as well as using this quotation sort of symbols here to mark a block of code as a quotation. We can actually also create the tree directly from the classes that are used to represent it. So here, this is the same a lambda function that does the cos of 5 times x in that class representation. So first we have to sort of set up a variable, and then I'd forgotten that if you shake stuff in OS X you get a larger cursor, and then we've got a lambda expression which will have that variable as its input, and then it will call the cos, and there you can see that we're actually getting the method info, which is what we need under the hood, and it will call cos with a single argument. So this is a list of arguments, but cos only takes 1, so we only have one thing in the list, and that's the argument we're feeding in is an expression that represents this variable that we bound at the entry to the lambda function. That becomes important in type providers because this syntax here will try and type check your code at compile time. But obviously, when you're writing a type provider, you're often working with types that don't exist at compile time. And so you end up having to use this notation here quite a lot. That's just another example there as well. I'll have a link to a GitHub account which has all these examples on later. Yeah, so you can see a call to a class member, so you get the type in there as well, rather than none. So it's a lambda on GUID, and you call it on some GUID rather than none for a static method. So those are quotations. There is more to quotations than that, but hopefully this will give you enough to be getting on with. And the reason for going into that is because effectively quotations in type providers are the demarcation between the code that is run by the compiler during the compile process and the code that you are injecting into the DLL that's being built. So this string here in a quotation, that will actually inject that string into the DLL that is being compiled and that you're sort of providing types to. And any expression you wrap in the quotations that sort of goes into this getter code or the setter code or invoke code on methods, that will always be in quotations, and it will always kind of be injected into that DLL rather than being run at compile time. Whereas obviously you might also have a bunch of code that, say, is running off and getting data from an API or from a database or from a website or reading stuff from the file system. And that code will not be in quotations. And if it's sort of within the type provider class and being run as part of that process, it will actually be being run at compile time by the F# compiler. I hope that made sense. If people have questions about that, then probably getting them up reasonably quickly would be helpful before we get too much further.
Thank you, Michael. And also, before we move too much further beyond Sergey's question earlier, did you want to quickly show how to add the setter code to the static property, or is that for later?
That's actually a good question, because I'm trying to think of how you would how you would actually do that on a static property, because obviously you don't have an instance of anything to kind of store your value on. So I was thinking it would be quite straightforward until I actually thought through the question, but now I'll actually need to think about it. So it might be I might need to come back to that at the end and probably work to that from an instance property with getter and setter. So sorry, Sergey, but I will try and think of an answer as I go along. Right, let's get rid of those examples for a moment. And let's move on to our next. Save that. We'll probably need to restart Xamarin Studio again in a moment. Okay, so let's add on to being able to actually give some configuration to our type provider. One thing you'll have noticed, if you ever use anything like the SQL type provider or the CSV type provider, or in fact pretty much any of the type providers, they'll normally take some parameters. So for the SQL provider, you have to give it the address and credentials to actually connect to your database that you want types generated from. If you use the CSV one, you need to give it a file name, those kind of things. So let's try and get that idea of having a parameter on the type provider into place, and then we'll kind of carry on from there and see what we can do. So this is called, they call it a static parameter for the type provider. So the first thing we want to do is we actually want to have a parameter. So let's add one in here. And you have to keep it a list because obviously you might want more. Really doesn't like me typing. It keeps on muting the. Parameter called a string. We'll have a type of string on that. Now, effectively, what we kind of do at this point is we provide a type, and we kind of attach a callback to it that will be called with these parameters when someone supplies a parameter to our type provider. So let's do that. We'll this is the one that will be given the parameter. So
you're muted again, unfortunately.
Is that back again?
Yes.
Yeah, no, it doesn't like the background noise of the typing. So
yeah, and unfortunately, I can't unmute you. I can mute you, which would not help. But
oh well, I'll try and keep an eye out for it. So this is a parameterized provider. So we'll call it provider. Why not? We'll have a base type of object again because we don't want to do anything fancy with it. So that's great. Now we need to sort of hook up this this kind of call in our sort of static constructor down here. We'll have our provider, and we can define static parameters on this provided type. So let's do that. And this takes a list of parameters, which we have. And then it also takes a function. You probably can't see the tooltip very clearly there, but it takes a function of which needs to take a string, an array of objects, and return a provided type. So we don't have that function yet. Let's pretend that we do. That we've got a create type here. So that create type we type creation type function. It takes a string, and this string is actually the name of the type that the compiler wants to use. So when you create a parameterized type from a type provider, the compiler will actually assign it a name based on the parameters it's been given, and then it will pass the name into this function. So let's go name. We also have our parameters. It's our array of obj, and then we need to return a type. So let's go down here and let's shift our property. Well, okay. So we need to pull out the parameter. So we defined, if we look back down here, we said that we had a list of parameters that's one long, and the first thing in it is a string. So sorry, it's not an array. It's I think it's a list of objects we're being given here. So we'll say that we're going to pull the first one out, and we're just going to assume it's a string because we've told the compiler that a string is the parameter we want to be given. So let's call it string. And going to get it, and we're just going to cast it to be a string. Yeah, it's an object, but a static property with the parameter as its value. Then we need to add the property to the type. We need, and then we need to return that. You're probably noticing by this point something which surprised me greatly the first time I used type providers, which is that despite the fact that they are an F# specific feature, they have the least functional interface I have ever seen in my life. Well, not quite, but they're getting there, definitely. I'll add a type annotation for that in a moment. There is lots and lots of object-oriented bits where you'll create types and then you call the add member method on it, and you set is static and getter code properties and all this kind of stuff. So that rather made my brain hurt. I'm not quite sure why that's the case for an F# specific feature, but there we go. Let me just double check whether that's right. So that can now go away because my type is going to we'll get a new back for each new parameter we supply. And create type needs to, it is an array of object. Okay, let's add a type annotation there because it hasn't managed to guess what that is. Okay, so there we go. We should have a full example of this point where what we're doing is we're providing this type provider, which is here. Provider has nothing on it at all, literally. It has, we're not doing anything with it in the slightest apart from hooking up this callback for a parameter. And then when that parameter is supplied, it will call this create type function with the parameter. We're pulling out the string. We're creating a static property with that string as its value. And then we're returning that a type back with the name that the compiler asked for. So let's build that, and then we'll probably restart Xamarin Studio again because that's in the script. Why are you trying to evaluate the script? That's a bit weird. Let's that out for a moment. There we go, build successful. If I reload this, I strongly suspect it won't find the new stuff, but we'll see. We've still just got static type. So let's close down Xamarin Studio and fire it back up again. You end up doing that a lot when you're building type providers. It takes longer with Visual Studio. It takes less with some other editors, but for some reason I managed to break my my Atom install shortly before I came online, so I'm using Xamarin Studio instead. I kind of swap between both of them in Emacs because I'm still... They all do different things, but there we go. Right, so having reloaded and cleared out the cache, we now have our power provider. Now what we're doing here is because we are actually creating a new type when we provide the parameter. So this isn't a let binding here. We're actually creating a type, and we'll have a type called, I don't know, hello Bob. And if we open up an angle bracket there, you probably can't see the tooltip that clearly, but it says that it wants a string as a parameter. So we'll say our string with a hello Bob type with a static property. And so there you go. We now have static property with hello Bob. So in theory, I think you could theoretically actually build something useful with this at this point. And maybe with quite a few limitations, but you can actually just get provided with a string at this point, and then you could go off in your type provider, you could do whatever you like with it, load a web page, whatever, and start providing types with pre-populated data and pre-generated properties on them. So not fantastic, but we're getting there. Haven't seen any questions for a while, so I'm wondering whether I've just lost everyone or whether this is making sense. I'm going to assume the latter.
So far, it seems to be making lots of sense. So I'd say carry on. I'm monitoring Twitter and some other things. So if anyone has questions, please feel free to use Slack, Twitter, or the Q&A feature here to ask questions, and I'll make sure they get relayed to Michael.
Excellent. Right. Let's move on to the next stage then. So we've got static properties. Let's see if we can actually create a class, with a instance property on it, and a constructor, and all those other useful things for classes to have. I do need to point out at this point a rather major limitation of type providers, which is one of the big frustrations with them, and anyone who wants a sort of fairly major open source contribution to get their teeth into, is that type providers can't currently provide F# specific types, which again is a bit odd for an F# specific feature. So for example, you can't generate discriminated unions or records from type providers, which is a bit of a pain really. But anyway, we can create classes with constructors, so we can do some funky things. So we'll leave our property in. Our parameter in. We'll still have a parameterized type, but let's see if we can add an instance property as well. Instance property we could definitely add a set of code to, but I think that will actually answer Sergey's question, unfortunately. So we'll have a provider property.
Michael, we do have a new question here.
Yep.
Christopher is asking, would a post-build action that restarted the F#I then copied the DLL over to where the #r reference is looking be a useful way to iterate during development?
Unfortunately, restarting FSI doesn't. Okay, restarting FSI allows you to reevaluate things in FSI, and that works, and that's fine. And I could actually do that here, just hitting the restart button. The issue is that for demos, that doesn't help so much, because for demos, it's much easier to demo things with IntelliSense. And what's actually getting kind of locked is the IntelliSense provider for some reason doesn't pick up the changes in the DLL for type providers. I don't fully know why. It's still a bit nicer than Visual Studio, because Visual Studio, as soon as you've referenced the type provider anywhere in anything that provides IntelliSense within Visual Studio, then you actually can't recompile it. It actually locks the file, and you can't run builds until you close that editor window and then restart Visual Studio. Closing the editor window alone doesn't deal with it. Sorry, just going to take a sip of water. So the answer is yes, it's nice for development, but it makes it hard to show what's actually happening, sort of with the nice pop-ups and things. So that's another. Let's as well. We'll unmute the microphone again. From our so far, getter code is a function, you'll notice, and in the example we're just ignoring the input. That input is actually a list of expressions, it turns out, and the first expression in that list, if it's not a static property, the first expression in that list is the actual class that you're that you've got an instance of. So what we're going to do here is we're going to erase our class to an object, because although we're going to store the information as a string in terms of what what will get embedded in the bytecode, we don't want people using our class as a string, because logically that's not what it is. So we're going to erase it to an object just to sort of stop it being passed around as a string by mistake or anything. So first argument that we are given, and we'll need to specify in there that we're expecting an object. It won't infer that in any way. So here you can see that splicing syntax that we used earlier. So this is a list of expressions. We're taking the first expression from the list. We're telling it that we expect that expression to be of type object, and we're splicing it into this quotation here. So it becomes a parameter to the unbox method, which is a generic method, and we've said that we're going to unbox to a string. Hopefully that kind of made sense to somebody somewhere. Let's also have a we may as well. So very similar kind of syntax here. We'll have a provided that's there's some string concatenation, very exciting, I know. So we're creating a method that will take a single string as a parameter. Is out for ages, and I thought that you couldn't create static methods for a while, because on property, the property on property is called isStatic, whereas the property on sorry, wrong way, on methods is called isStaticMethod, and it took me a while to realize that it actually existed. And then rather than getter code, have invoke code instead. And so we take some arguments here, write some code to run, again in a quotation, because this is code in the quotation is code that is going to be run at runtime and will be embedded into the DLL that you're providing to. So as I said, this is a list of expressions. The first one, if you're not static, the first one is always the instance of the class that you've got. I'm just looking at the time and realizing we need to press on. And then any further ones in the list will be from the list of parameters that you've asked for. So here we're going to have a two-element list. The first element in the list is going to be the instance string, and the second element is going to be the string, the prefix parameter we've created just there. So obviously it's a prefix, so we'll grab that one first. are very keen on muting me at the moment. I don't. We know that's a string. And then we also have our unboxed. I'm just going to go off the edge here because it's not that exciting here. So this is just a repeat of the code. That's an obj. And obviously, we've got two strings which are being concatenated in here, so our return type will be of type string as we said it should be. Now this is great, and my favorite mistake when building provided types is that we now have an instance method and an instant property, but we have no constructor. So there is currently actually no way of creating the an instance of the type to use any of these instance bits. So let's have a constructor. The naming here, so we have a provided constructor. Again, this is effectively a function, so it takes a provided parameter list. Instance string, and it's of type string. And then code, and the invoke code here, obviously for a constructor, you don't have an instance of the type already, so you don't have a kind of a self object at the beginning of the list. You just get given the list of parameters that you've asked for. And the thing you need to return is the underlying CLI type that you're saying that your provided type is based on. So we're still basing our type on obj. So our invoke code for the constructor will need to return an object. And that will then become the value of the constructed type. So let's this is kind of the reverse of the unboxing of. So we get our first argument, which we know will be string. Build that out. William is saying something about I can disable Google Mute defaults. Where do I put that in? Is there any way of running that whilst the Hangout's actually in process? Do you know, William? I'll let you. I'll carry on for a moment whilst that happens. Gabriel, you're asking about can you have one with two copies of Visual Studio open, one with the type provider and one with the thing that's using the type provider. I don't think you can. I think it still locks the file, but I could be wrong on that one. Definitely, you don't get updates to the type provider when you recompile it in the other copy of Visual Studio. And yes, unfortunately, everyone is having the sound stutter because it seems to be auto-muting me when I start typing, which there is some way of turning off, but I'm not quite sure how to set the option, apparently.
Basically, from what I can tell, it looks like you would have to restart your browser in order to fix the problem.
Okay, I'll know for next time. I should have done a longer test. Right, so we'll comment out our script again for the moment, and I'm not quite sure why it's trying to build the script. I wonder if I can. Aha, I can tell it not to. Great. And let's see what happens. Saying this constructor isn't defined, but we'll because asking if I've ever used a provided static constructor. No, I've never tried it. I do seem to remember reading a question from someone else somewhere, might even have been you, saying that they'd had some problems when they tried it, but I don't quite know what that was. Hello Bob with the name of Bob, and I'll just restart Xamarin again. So do that, and and I've forgotten something because I'm doing well here. So with my type here, we're back to the object-oriented interface again. We've only added the static property here. So my bad apologies for that. We also need to add all of the we had something called my instance prop and my method. Not to speak whilst I'm typing anymore. We'll add the constructor as well. There is an add members method where you can add multiple things to a type at once, but unfortunately, actually, each of our things here is a different type, so it's a pain creating a list of them to feed to the add members method because you need to upcast them all first. So I'll just do them on separate lines. Take a sip of water. See if I need to restart or if I can convince this to. I might cheat slightly. I'll restart interactive, and even if IntelliSense tells me that I can't do that, if I actually run that in an interactive session that's restarted, you'll see that actually we have provided, we have created a hello Bob value, which is a hangout live.provided.paraprovider. And if you actually did a full print out of this rather than a summary, a full print out of the type name, you would see the parameters are actually serialized into the type name. And it also tells you the underlying CLR runtime value of hello Bob is a string of Bob. And if we have it here, we call it, what did we call it? Instance prop. Instance property. So that's our instance property there, which has a value of Bob, which is nice. Apply a prefix, so we'll call him Mr. Bob. There you go, we have our Mr. Bob. So there you go, we've actually provided some code which is being run there rather than just a sort of static value. So that's our method here with its quotation doing the string concatenation. Now, one thing I should explain at this point, it comes into sort of the fact that it serializes the parameters into the type name. It also needs to know how to serialize the values that you kind of inject into the IL. So one of the limitations of these quotations is that you can call any public things that you define in your assembly. So if I go up here and I define a public method in my assembly, then in my quotations I can use that, because that's still something that will just be compiled into this assembly, and this assembly will be referenced by the thing that's being built. So that's a valid piece of code. But if you try and actually put a literal value in there, it has to be something that the expression, sort of the expression to IL generator knows how to generate. And unfortunately, that basically limits the things you can embed into your quotations to being strings, the number types, and arrays of strings and the number types. So you need to be quite cunning in terms of how you sort of create your underlying object, and it often ends up being a kind of map of string to string with some nasty little serialization and deserialization moments. But that's unfortunately just one of the limitations that we need to work with. Okay, so that's all fine. We've created a class now, and so we've got half an hour. There's one more thing I was kind of wanting to comment. There is another question as well. What type provider constructor, not static, should return in the case of a generative? I'm going to leave generative type providers for a moment, I'm afraid, Sergey, because I've actually not, I remember it's different, but I've not actually worked on one for about a year, so I can't honestly remember the differences off the top of my head.
Maybe we can have a round two at some point where you can talk about the generative providers. Generative
type providers, yeah. They type providers in general are a bit of a black art, and they're a sort of slightly different black art. Gabriel, you're saying, are we only limited to primitive types? The types that are provided can be as complex and as deep as you like. What you are limited to is things that pieces of data that you get at compile time. So you're in your type provider, you've gone off, you've read some data from an API, or you've grabbed it from SQL Server or whatever. If you actually want to embed a value rather than a piece of logic, you need to be able to represent that value with a primitive type. Yes. Does that kind of make a bit more sense? You can post a follow-up question if it doesn't. So the type you're providing doesn't have to be primitive, but if you want to retain any of the data that you've obtained at compile time in that type, you have to be able to kind of serialize that yourself into a primitive type of some kind. Okay, so hopefully this should give you kind of the bare bones of the things that you would need to start creating a type provider of your own. I'm hoping this kind of gives the idea that you could, if you wanted to rebuild the SQL type provider, you could take a connection string to a database, and you could go off and you could add properties representing each of the columns in the table, or that kind of thing, or you could parse the string that comes in as a kind of template language and pull back and sort of provide a render method that had a sort of strongly typed, took a strongly typed function to take things in. I'm actually working on a type provider that does something similar to that at the moment for creating translatable strings within DLLs. Excuse me. But the one other thing I wanted to play with, which I think are a really nice feature of type providers that came in slightly later than the main type provider mechanism, is that as well as adding static parameters to your type provider and providing a different type depending on what that parameter is, one thing which got added, I think, I can't remember which version of F# it was now, which is a bit embarrassing, but 4.1, I think. You can actually attach static parameters to methods as well. And this allows you to have methods which, depending on the static parameters they take, they actually return different types. So let's see if it's kind of a kind of a poor man's dependent types if you've ever played with anything like Idris or that kind of thing. So let's see what we can do with that, because I actually think this is quite a nice feature and opens up some possibilities for type providers that you otherwise kind of wouldn't be able to get to. So the parameters on the methods function in a very similar way to the static parameters on the types. So we'll need a create method function. So I've create method function. It needs to it takes a method name, just like the create type one does. Again, the compiler will actually supply the name it wants this method to be given. So we then also take an array of parameters. So again, I'm going to take a couple actually. What I'm going to do is I'm going to create it's a really silly method. I'm going to create a method where you can feed it. One of the first parameter is an integer, and that's how many parameters it takes. Each of those parameters is itself an integer. And then it will just add them all up and either give you back a have you already seen the use of F# for static parameters in real-life TPs? Yes, as I said, I'm building one at the moment. It's quite useful, and one of the SQL command type providers uses it, I believe. So yeah, I'm going to take an arbitrary number of ints, add them all up, and either give you back, and then you can say whether you want an int or a string representation of the result to come back. So we'll have a parameter that's an int. We'll have a parameter that's a string where people can either say string or int. So we're going to want some parameters for this method to take, and we can use a list comprehension to build those up. Creating a list of parameters that our function is going to take. So you can see that this is, we can programmatically generate that list. Doesn't need to be static at all. And then we're going to want to have a different return type depending on whether they say string or they say. So they say string. The compiler has given us the method name, so we need to use that. The method parameters. And the return type is a string. And if they say int, then off we go. And we should get a method back. So that's a little helper there. And if that's and we'll just throw if we don't recognize that parameter. So there we go. So that's fine. So we've got a little helper method here for creating our function, creating our method. Sorry. Let's now add in our little dependent method, whatever we want to call it. So I'll add it at the bottom here in the hope that I won't get to add it to the type afterwards. So we need a provided method here. But the interesting thing here is that our initial dependent method actually doesn't have any invoke code, and then basically it will get swapped out with the method that gets returned by our callback function. So let's get that in place. The thing which is going to get swapped out, we'll just give an empty list for the parameters. We'll say it returns ob, and we will say that it's not static. But at the moment, it says that it takes no parameters, it returns an obj, and it has no invoke code. So that's not a terribly useful method in its own right. So let's get that set up. So we need some static parameters, which it's going to take. The fact it keeps on muting me is quite distracting. But there we go. So we've got the two parameters that we want to be able to attach to this event. And we then need to actually hook those up. So we'll want to, you'll notice on the, in our helper code up here, we haven't actually given any invoke code. So we'll need to get that set up as well. So let's find our new method. So got caught out typing and speaking at the same again. We need the type that the method is going to be attached to. And our so I've got no, this is not what I wanted. I've written a whole load of this code already. That's what I get for so this here we can use our our little helper method, create method here to get our basic method type. So there we go. So now we have our, I'll call it method. So we have our basic method with its inputs and how many inputs it takes and what return type it has. We then need to build. We then need to build up an expression that will add all of these numbers together. So let's quickly knock together something that does that. We're going to fold a list of expressions together. So this is our code that's going to sum things up. I'll leave you to think a bit about how that works, given we're getting near the end of the slot of time. So as you can see, I'll give a very quick explanation and then leave you to think about it. But basically, it takes an expression, and each time you go through, it takes the previous expression, splices it in here, and then adds in the next parameter in the list. And we're going to take a list of expressions, and we're going to skip the first one. The reason for that is because those expressions are going to be the list of input parameters to the method. But if you remember, the first parameter handed to the invoke code is the instance of the object itself, and on this occasion we don't care about that. We're just going to ignore it, skip that first one, and carry on. Another expression that can convert something to a string, in case we want to convert something to a string, which we will in a moment. That just wraps an expression that evaluates to int in a call to the string function. So that will turn it into a string. And we'll whether it's a string or an int. If it's a string, then we want to convert our sum. Otherwise, we just sum up the arguments. And then at this point, I believe we should be able to. Sorry, I forgot about the muting. We should be able to set our invoke code to that. And return that method. This is, so if you remember, we built our dummy dependent method here that takes a couple of parameters and doesn't really do anything at all. This defines the thing we're going to replace it with. And let's, we'll need my type a bit higher up in a moment. Let's add our static parameters to that method then, using this define thing. Oh yeah, and we need to actually, I think in this particular occasion, we can take that out because my type, or we can take that out because my type is in the current scope. Okay. Then, what do we call our thing dependent? So, define our static parameters. So we give it our parameters. We give it our function. And that should do the job there. And then we just need to make sure that we actually
quick question. Mark Gray is asking, what is going on in line 81?
Line 81. Okay, right. So here, a method needs to be added to a type to, and so here my type is the type that we're creating to provide a type definition that we're adding all of these members to. All of the members that we're creating, kind of statically isn't quite the right word, but we're creating, we add them in here. But if you want your parameterized method to actually work within the callback, it needs to add itself to the type that it's a member of, which is slightly bizarre. You would kind of assume that because the callback method insists that you return a provided method, you would have thought that that's actually what it would do when it got that method back, but it doesn't. So you need to make sure you add the method to the type that you want it defined on. There might be occasions where it's useful, but it doesn't. But I can't think of any offhand. So I'm aware I've kind of rushed this last bit slightly. We're running out of time. Let's see if I have actually got that right. 0 errors and 1 warning. That was an incomplete pattern match. I don't care about incomplete pattern matches at this point. And this one I am actually going to restart because it's actually quite cool to see the IntelliSense on this one. So let's do that. Let's see if this is actually worked. So we've only added stuff, so this should all still work, which it does. But we should. And this took our and so you see there we've got a method that takes one integer and returns a 1, and there you can see it's returned a string of the value 1. But that's a bit boring, so let's go for something slightly more exciting. Not very much, a little bit. And here you can see the compiler knows that because we've said that we're going to take 5 input parameters, we actually need to supply 5 input parameters. And there it's adding them up and actually passing back the int. And I've actually found this one of the most useful properties in type providers is being able to do this, because it kind of opens up possibilities, especially around things where you actually have all of the information already on the local machine. It's just that you want a way of representing it, or you want to be able to use a format that's used in other places. So as I said, the one I'm currently using it for is there is something called the ICU format for providing strings that need translating, which has a whole bunch of tooling around, and quite a few translators know how to deal with it. But one of the things it allows you to put in placeholders for things like the gender of the person being talked about, or a number, or a date, or a length of time, and these kind of things. And it means that we can build these kind of static methods where we take one of these strings and we actually parse it according to the spec, and we know exactly what information needs to be provided at runtime for that string to be successfully translated into the different languages. And so that's been quite a fun project, and it's just sort of starting to come together now. But it's bang on 8 o'clock. I can be online for a little bit longer, but I don't know if we want to wrap up the session sort of officially at this point. And yeah, any more questions, feel free to fire away. And sorry, Sergey, that I've run out of time to come back to your static property one. I will try and have a think about that, because I'm having a complete mental block on how to actually do it myself, so I can't help you out immediately. So yeah, Any questions?
I don't see any in any of the channels I've been watching. I do have one maybe you could use as like a blog post example at some point. But one thing that I have been trying to do at some point was base something on like a collection or a list, and actually add like basically have something that you could iterate over, and then add as static properties the actual elements of that collection that you could reference like directly to get access to it. Or again, you could iterate over the list to use the instances that way.
Yeah, okay. Well, yeah, I can try and knock together a short example of that sort of over the next few days, because as I was saying earlier, that's actually sort of quite a standard way of representing your type in the underlying CLR is something like a list or a map or something like that. Mm-hmm. Yeah, we can I can have a look at that. And
it seems like it shouldn't be too terrible to do, but it's
no.
It was challenging when I attempted it myself earlier.
Oh yeah, sorry. Good question from Christopher. I actually gave a variant of this talk a few days ago, so hence the bizarre naming. But all of the examples here are online. Let me just quickly. It's actually called the Cambridge Type Provider because I gave this talk in Cambridge. And so there's a GitHub repository here. You can go there. You can browse to it. I'll put a link to it as a comment in the Hangout in a moment. But basically, what it has is each of the steps we've walked through. It has a separate FSX file that represents that step in the process. So if you go into minimal, that's just the type provider all the way through to. If you go to dependent function, that's basically the code you've just been looking at. So you can cut and paste your heart's content on that one. Let me just paste that link in if it will let me. Apparently I can't. Oh, there we go.
Yeah, maybe we can put this in the YouTube reference of the recording, and also put it on the Hangout once this is done, so that people can access it more easily.
Yeah. So that's that one.
It's like Max has a question.
Yeah. Would it be possible to save the state into the underlying type for the static property to be able to set it later? I don't know, Max, is the simple answer. I'm not tried playing with settable static properties, and I don't think you can do a static constructor. You might be able to. Yeah, I'd have to try it. I've never tried it before, and most things in type providers, they don't always follow quite such a sort of consistent logic as you would like them to. Thanks to the guys in Toronto. It's nice to know it kind of made sense to somebody.
All right, so we'll look for. I'll try to add this link to the source code onto the Hangout reference and onto the YouTube reference. We'll look for the blog post on the question I asked. No pressure. And at some point we'll try to schedule another one where we actually talk about generative type providers, because I know several people have expressed interest in those, and those seem to have been a little bit more.
They're definitely interesting. They have their own.
And there are fewer examples of those that I've seen.
There are definitely fewer examples of them. I have tried a couple, but yeah, a comeback session would be good. I'd need to brush up a bit on that one.
Well, you just let us know when you're ready. And Michael, thank you again. For those of you who are looking for help with F#, remember that Michael has his own company and would be happy to assist you. You can find them at maven.co.uk.
Yeah, shout out also as well to I'm kind of available for short-term things like training, but I'm actually doing a lot of work with guys at Logibit, so I just want to say hello to them as well. I think one of them's even online listening. So, and thanks for all the questions. It's always good to know that people are actually listening, especially because you can't see the audience. So keep the questions coming.
Yep. And as noted, this has been recorded. I'll post a link to this, and also the one that Phil did a couple of days ago that I forgot to link to. Those links. They are available in the YouTube feed for Community for F Sharp. So if you go to c4fsharp.net, you'll find a list of all of our, well, there's 2 links at the top, one to Vimeo, where we hosted our older recordings, and then the YouTube feed has our newer recordings from, I guess, the last year or so, maybe the last 2 years. So lots of content there if you're interested. We also have a few more coming up next week. Scott Washington will be joining us to do kind of a code review and refactor. Repo to be determined is last I heard, so that should be a lot of fun.
Can I volunteer one of mine?
What's that? Oh, yes.
Can I volunteer one of mine?
It very well may be. And then on Wednesday, Yan Kui, who was supposed to present this past Wednesday at F Sharp Bristol, had to reschedule, so that will be a live feed of the F Sharp Bristol meetup on Wednesday. I think right around the same time, I guess 6 p.m. or 7 p.m. GMT, which is around I guess 1 or 2 p.m. Eastern time in the US. So please join us again for those. That's Tuesday and Wednesday next week, and then we have again more things coming. So we've definitely tried to make up for the missed months and kind of more random. I guess we're still random in terms of when we have these things, but we're trying to get more content to you. So if you have suggestions, please push those out and let us know. If you would like to present, we're always happy to have more people present. And even if you're just trying to get prepared for an upcoming conference or other meetup, we'd love to have you on here and give you a shot at giving a demo run. Or again, if you're a user group, much like what we're doing with F Sharp Bristol, we're happy to host a live feed or even try to set up a live feed from someone who may not be in your area to host or to present at your user group. So let us know. Again, you can reach out at C4F Sharp. And you can also find Michael at Mavin, at MAVNN on Twitter, and again, mavin.co.uk. So anyway, hope you had a good time watching this, and the recording will again be posted very shortly, so you can review anything that you might have missed, and I'm pretty sure Michael will be happy to answer any follow-up questions you may have. All right, any last words, Michael?
No, I don't think so, but thanks for the hosting, and it's been fun. I hope it's helped.
Yeah. And I see Mark has asked, can we organize a hangout for his meetup sessions? And absolutely, we'd love to help schedule that and host that. So long as you don't mind us recording it for the benefit of others or letting others join in remotely, be happy to help us organize a hangout for your local meetups. So, all right, thanks again, and we'll catch you next week, Tuesday and Wednesday.